6.5 Reduction-Oxidation Reactions. Another set of reactions which are included in our discussion of energy are reduction and oxidation reactions. These involve the movement, the flow of electrons from one molecule to another. We can use the term oil rig to help us keep oxidation and reduction reaction straight. Oxidation is the loss of electrons, so OIL, oxidation is loss. Reduction is gain of electrons, so the RIG in RIG stands for reduction is gain. Redox reactions must always occur in pairs because the electrons are moving from one to another, and so one molecule is being oxidized. It is losing an electron. That electron must be picked up by another molecule which is going to be reduced. Now, if you remember from back in lesson 2, electrons are tiny little bundles of energy, and so as electrons are being passed from one molecule to another, this is energy flow. This is the smallest little bit of energy that can be passed from one molecule to another. In biological reactions, usually redox involves the movement of hydrogen. So a chemist would tell you that redox reactions are the movement of electrons. That is true, but normally in biological reactions that electron is accompanied by a proton, and this makes a hydrogen atom. And so as we look at these equations, it's easier to watch for the movement of hydrogen than it is to chase tiny little electrons around. Now we can still use oil rig. Okay, so the loss of a hydrogen is oxidation. Remember, oxidation is loss of an electron or loss of hydrogen. And so the gain of hydrogen or the gain of an electron would be reduction. Reduction is gain. In lesson 7, we're going to examine cellular respiration. In cellular respiration, fuel molecules are going to be oxidized, and we remove energy from those to make ATP. This is the summary reaction for the cellular respiration of glucose. So C6H12O6 is glucose. So the reactant glucose plus oxygen, and the end products are carbon dioxide and water. And this is just the summary reaction. As we will see in lesson 7, there are many, many small steps that take place. But if we look at this summary reaction, and keep in mind that the glucose is going to be oxidized, okay, something else has to be reduced, and the oxygen is going to be reduced. So if remember our oil rig, okay, oxidation is loss, the loss of hydrogens. So if we strip all of the hydrogen away from the glucose and we pass that over to the oxygen, and now look at the end products over on the right hand side of the equation. If we strip hydrogen away from glucose, it's converted into carbon dioxide. And if we add that hydrogen to the oxygen becomes water, H2O. Again, it takes many steps. We'll be looking at these in lesson 7. This is a very highly exergonic process. This oxidation of the fuel molecules, we are releasing energy. That energy is used to make ATP. Photosynthesis, if we flip this reaction over, again just the summary reaction, we can take energy from sunlight plus carbon dioxide gas plus water and convert that into glucose and release oxygen. So in this case, it's the water that's going to be oxidized and the carbon dioxide gas is reduced. So again, if we take that water molecule and we strip away all of its hydrogen, it becomes oxygen, which is one of the end products. And if we add that hydrogen to the carbon dioxide, that carbon dioxide can be used to make glucose. This is a very endergonic reaction, and so it requires energy, and that energy comes from sunlight. We will be looking at the process of photosynthesis in detail in Lesson 8.